Hello friends, in this video I'm going to tell you how to write ionic equation, ionic equation. So suppose I have a equation, chemical equation like HCl and plus NaOH, sodium hydroxide, and it produce when we react with HCl with NaOH we'll get salt NaCl and water. Fine. So I can write this at the bottom, water. Fine. So all are in aqueous form. So notice that guys, Na plus. So if we uh, since HCl and NaOH, HCl sodium hydroxide and NaCl are electrolyte, strong electrolytes, so they easily dissociate into their ions. So HCl will make H plus and Cl minus, and sodium hydroxide will create Na plus OH minus, like so. Let me do let me dissociate all the ions and then create a equation, chemical reaction. So suppose uh, so this will be H plus, HCl will be H plus and Cl minus, and sodium hydroxide will be sodium plus Na plus and OH minus, and it produces Na plus and Cl minus M plus water. So if we dissociate, so guys, if we notice the sodium and chlorine, sodium or chlorine never really react. They are floating around the beginning and still floating around at the end. So thus a better equation for what is actually can be, that can be right, like, so thus a better equation for what is actually happening would be just H plus and OH minus. So this is just floating, nothing else. Only the reaction, only reacting, since the H plus is react with OH minus, and it produce only water. So you will notice that sodium and chlorine ions is not actually reacting. So they are all waste. So if when we conclude our reaction, so we just have to basically we need just have to neglect Na plus and Cl minus. Fine. So since we have neglected sodium, Na plus and Cl minus because they are not really involved. So if you want to emphasize that H plus is hydrated, then you can write S3O plus and OH minus. If we hydrate H plus, since we are adding OH, H2O with H plus, we'll get S3O plus and minus, and we'll get two molecule of water. Fine. So that's how you write. So what can we conclude that? So you just, whenever writing or any net equation, just remember that break up all the substances and only break the strong substances. So first point is break strong electrolyte, break only strong electrolytes, first point. And second is delete or remove all ions or any ions that appears on both side. Just remove all the ions that appears on both side, like let me write first and then I'll explain you. Both side of the equation, of the equation. Fine. So the clearly rule 2, rule 2 basically is tricky one. You must know you tricky one, the one the first one rule is very much tricky, because you have to identify which are strong electrolyte. So let me tell you first thing. Strong acids are like HCl, HBr, Hi, NHNO3, HCl. So these are strong acid like HCl and HBr, HBI. So these are like a strong acid, or H2SO4, sulfuric acid. And if we talk about salt basically is not a strong electrolyte, just remember that. So this is a matter of memorizing the 7 strong acid and checking for the presence of metal ammonia. Note that all the strong bases contain metals, and all the salt contains either metal or ammonia. Just remember that. So what is the second rule? Second rule says that delete all ions that appears on both sides of the equation. So just remember this. If you notice in above reaction, the sodium and chlorine ion appears on both sides. Can you see it? So chlorine and sodium ions appears on both sides. That's why we have removed it. So we left with water only. Fine. So they are actually floating around it, but they are not actually reacting when we see. So when we have a question like there is a reaction in which ions appears on both sides, then just remove all the ions and your net reaction will be after removing all the unnecessary ions. So yeah, thanks for watching. Bye bye.